Imagine you've got a huge game sales dataset. It's got consoles, publishers, genres, sales numbers, and review scores. You want answers fast. You could spend minutes writing clunky formulas, or you could let Excel's dynamic array functions do the heavy lifting. In this lesson, we'll master 4 core functions of data analysis: unique, filter, sort, and sort by, using 12 quick examples from our dataset. Once you know this, you'll start thinking differently about how you work with data. The first function, unique. What it does? It returns a list of unique values from a range or array, removing duplicates. The arguments are following: array, the range or array to check for duplicates. Second, by call. It's optional. False checks rows, true checks columns. It is rarely used, but if your data is horizontally aligned, you can check it out. And the third one, exactly once. False keeps the first occurrence of each value by default, and true only keeps values that appear exactly once. Why use it? It's great for quick overviews. Instead of filtering manually, you instantly see all unique entries. It can generate a list of unique values not only for one column, but for multiple as well. Let's see how to use it. Let's say you've been asked which consoles are even in this dataset. You don't want to scan 6,000 rows just to find out. So type =unique and choose your console column. The data console means our column with console names. Unique removes duplicates automatically. If a new console appears, the list updates instantly. Quick tip: use this to build drop-downs that always stay up to date. It's awesome. But pay attention, it's case insensitive. The list also won't be sorted by default. For structured data, I recommend to use tables, like here, to automatically cover new rows. Now the second example. You want to find publishers who released only a single title, maybe indie developers or one-hit wonders. This is different from just unique publishers. You want the ones that appear once, exactly once. So type unique, choose your publisher column, then type comma, true. The third argument, true, tells Excel to return only those publishers that appear exactly once in the list. So if Big Games Incorporated appears 15 times, it's excluded. If Tiny Indie Studio appears once, it's included. Why is this useful? It helps to identify niche players potentially useful for focused marketing or partnership analysis. As you can see, the second argument is skipped with a blank comma. It's done to keep the default row-based comparison. By the way, watch out for inconsistent naming, like extra spaces, typos. Clean your data with trim if necessary before using. Now let's explore the second function, filter. What it does? It returns only the rows or columns from a dataset that meet certain criteria. It can replace manual filtering with formulas that auto-update. It's perfect for pulling out specific subsets of data, and it always keeps your analysis dynamic and reusable without applying filters. The arguments are following: array, the range or array to filter. Include a logical expression or array that determines which rows or columns to return. And if empty, the optional argument, is the value to return if no results match. Let's say you want to extract every row about Nintendo Switch games, maybe to send to the marketing team or analyze sales trends. So type filter, select your dataset, and choose the condition console equals NS for Nintendo Switch. The last argument is no results. The condition tests each row's console. If true, the row is included. The result is a dynamic subset, showing only Switch games. If new data is added, this list updates automatically. No results is a friendly message shown if there are no Switch games. This avoids scary Excel's calc error. Some quick tips. Always ensure that the height of your dataset range and your condition range are the same. Text comparisons are case insensitive, but be careful about extra spaces or inconsistent naming. This is a powerful way to create live filtered reports without manual copy-paste. Let's move to the next one. Identify top-tier games that received outstanding reviews, above 9 points. It's perfect for quality control or spotlight features. The formula is pretty similar. Our data range, then Metacritic score, greater than 9, no results. The condition here includes only games with scores above 9. The formula returns full rows, matching this filter. The optional no results message handles the case of no matches. Also, make sure the critic scores are numeric, not text, otherwise the comparison may fail. This kind of numeric filtering is a fundamental analyst task. Dynamic arrays let you do it in seconds. But what if simple conditions aren't enough? For example, we want to get only top-rated Nintendo Switch games, so we have two conditions. If you have more than one condition, you should wrap all of them in parentheses for complex filters. Use the asterisks for AND logic and plus for OR logic. I know that for newcomers this might look a bit tricky, but if you will always test each condition separately before combining, you will have no problems. So let's try it out. As you see, the result is correct. Both conditions are met in each row. Sometimes you want rows matching either condition. For example, games released on PS4 or PC. Here we will use the plus operator. It adds this array's element-wise. If either is true, the sum is 1 or greater, so true. This acts as logical OR. Rows matching either platform are returned. You can always extend this with more conditions, and the conditions may contain their own formulas. Let's demonstrate it through filtering games released after 2023 for PS4 or PC. In the first condition, I will use year function to grab the year. So if the year is greater than 2023, the condition is met. Now I will add an asterisk and open the other pair of parentheses. Here the condition is like before. Here parentheses group or conditions to apply them correctly inside AND logic. By the way, make sure your release date is an actual date, not text. Or use dateValue function if needed. This kind of filtering is exactly how analysts carve out specific cohorts. So let's move ahead. The sort function. What it does? Obviously, it sorts the rows or columns in an array in ascending or descending order. It saves time compared to repeatedly applying sort in the UI. And it also keeps sorted results dynamic when source data changes. The syntax is following. The first argument array, the range or array to sort. The second is sort index, it's optional, column or row number to sort by. The third is sort order. It's also optional, 1 for ascending order by default and -1 for descending. And the last argument is by column. It's optional too, and false by default sorts by rows and true sorts by columns. Sometimes it can be useful if your data set is horizontally aligned, but it's for rare occasions. Quick tips. You can omit sort index to sort by the first column, and it can be combined well with unique and filter functions. Let's sort the genres alphabetically. Use unique, the genre column, and apply sort. The first function returns the distinct genres like action, puzzle, and others, and sort orders the list alphabetically from A to Z. Sort defaults to ascending order. Specify -1 to reverse. Now let's say that your boss wants to see the top-selling games ranked. We will start by typing sort, selecting our dataset, and the second argument will be 8, the number of our total sales column. The -1 is for descending order. Select your column index carefully. If your data shifts or you use tables, indexes can change. Tables use structured references for safer referencing. For huge datasets, sorting full rows can be slow, of course, so consider filtering first if possible. The last function for today is SORTBY. It sorts an array based on the values in one or more separate ranges, even if they aren't included in the final output. It lets you sort your output by multiple custom criteria without arranging the source table. The arguments are following: array, the range or array to sort. By array is the first range array to sort by. The next argument is sort order, like before, +1 for ascending by default and -1 for descending. You can add multiple by array conditions and multiple sort orders for multi-leveling sorting. Let's see your games ordered from oldest to newest by release date. So let's type sort by. The first argument is the titles only, so you get a list of game names. The second argument is the release date column. The third argument is our sort order, 1 for ascending, so oldest dates come first. Sort by lets you sort by a column not in the output. This is useful when you want a sorted list rather than a full table. The key is to efficiently combine all these 4 functions. Let's see some more complex examples. In the next one, you want to focus on recent genres and present them alphabetically. Sorted unique genres for games after 2022, to be exact. So we will use filter function that keeps only genres of games released after 2022. Then unique to remove duplicates from the filtered list, and sort. It puts the final list in alphabetical order. Filter first, then unique, then sort. Order matters for accurate results. Now let's say a reviewer wants a list of PS4 RPGs ranked by how well critics liked them. Use filter with 2 conditions, then sort. The 7th column for Critic Score and -1 to make it in descending order. As you see, dynamic arrays transform how analysts interact with Excel data. By mastering these 4 functions, you can build live, update, on-change dashboards and reports with minimal fuss. And importantly, your formulas become easier to understand, maintain and debug. But as you can guess, These four functions are just the tip of the iceberg. There's so much power waiting to be unlocked with dynamic arrays. So stay tuned for the next lessons. We'll dive even deeper and make your Excel work smarter, not harder. See ya!